All right, so this lecture we're going to start reviewing some Python basics, and I've borrowed some slides from another textbook. It's a Fundamentals of a Python First Programs. It's the second edition, published by Cengage. So I'll basically just go through, and some of the slides are modified and just for what we need in this class. And start with some very basics, all right? Okay, so now Python is just like any other programming language. It's actually many of the concepts are going to be very much familiar. And I also suppose you already have some basics in Python. And if you have programmed in another language, and then you should have noticed the similarities, but there's also differences. So one of the first, fundamental idea is talk about data types. And a data type is basically it's an abstraction of a range of values or a set of values, and also the operations you can do on those values. And we're going to look at some of those data types, and there's actually only kind of a limited amount of data types that supported by Python, basically the built-in ones. And then another concept is literal. And a literal is the way a value of a data type is represented in your code. And now this literal could come from multiple sources. It could be in the source code. It could be coming from a file, or from communication with a different program over the network. Now, some of the basic data types that's being supported by Python, one is called int. Int stands for integer. And the float, those are for the floating point numbers. And so these are the numeric data types. And this is how you represent numbers. Now, so if you got integers, in Python, the type is called int, although you don't really, usually don't need to specifically use this type name, int. But in certain occasions, you might use it. Now, these are some of the example literals. You got this, next to 1, 0, 1, 2. And so this is basically, you're familiar with. And then you got real numbers. And the real numbers are presented in floating point. Now, the floating point is not 100% accurate, because not all the real numbers can be represented in a computer, and which is fine. So then there's this concept of a precision. The precision is, the measurement of accuracy that we want for those floating point numbers. All right, now, so some of the examples, basically to use the literals that represent float, you have to have the decimal point in there, okay? And you may omit the beginning 0 and like .3333, it will be 0.3333. That's what this is. Then you've got a very common data type that you have to deal with. It's the strings, the character strings, and the type name in Python is str, that represents a string. Now, so here are some examples. You can use double quote or single quotes. It doesn't make a difference. You may have an empty, this here, the second one is an empty string. So a string literal is basically a sequence of characters in single or double quotes. And we just saw an example of empty string. And so here's some of the examples here, just put what your, put your text in a quote. So this is a literal string. Now you may use the built-in print function to print. Of course, this is going to print that string without the quotation marks, because the quotation marks are how you use to represent that literal in your source code. Now, you may also have multi-line strings. The multi-line strings are represented with triple quotation marks, either single quotes, triple single quotes, or triple double quotes on both sides. So you may have a long string broken down into 2 lines here like this. And this is fine. This will, in this particular case, the new line that's breaking this long string will be ignored. It becomes simply just an empty string, or it becomes a space. This is how it prints out. What if you want a new line? When you do want a new line, you just use this \n. That's a escape sequence. So the backslash is the way to escape not just a new line. There's other things you can also escape, the things that is not printable, for example. Now, a couple more escape sequences, like backspace, new line we just saw. You may have tabs and the backslash character itself. So use a double backslash that represent 1 backslash. Quotation marks, you may also need to do that, because if your string is wrapped in a single quote or double quote, you may need to use that quotation marks. If it's a different quote from the surrounding quotes, and then you don't need to use it. Concatenation. So it means, how do you make a string that's broken down into multiple pieces, put them back together through concatenation? So this operator, this plus operator, if it's on the numbers, that would be addition. When it comes to strings, this usually means concatenation. So you can have this 3 different string objects concatenated like that. All right. Now the string object also supports an operator that makes it interesting. And this asterisk, again, on numbers, this means it's multiplication, but in the case of a string, and then times 10, that means repeating that 10 times. Okay. Variables and the assignment statement. So a variable is basically a name that's associated with a value. And to be more precise, that name is actually called a reference. So I may not go into details about what references are, but just think of that as is like a name that's pointing to a value somewhere. The value is an object itself, but the variable, it's another way to refer to that value. All right. Now, there are some restrictions on the variable names. Don't use the keywords. If there's keywords, they are part of some other things, then we're going to look into some of those statements, the if statement, the def for defining a function or a method. And then you have import statement. So those are some of the keywords. You don't want to use them in your variable naming. And also the name must begin with a letter or underscore. There's a specific meaning of underscore. If you start with this, this is sort of a naming convention is important in Python. And normally you don't want to start your variable names with an underscore. And the names are case sensitive, so that's a no-brainer here. So the weight, for example, in all caps is different from the all lowercase weight. All right. So the preferred naming for variables and other entities is through this underscore separating different words, and they're all lowercase. Now, there are cases for upper case variable names that's usually representing constants, the things that you don't want to modify. And that's just a naming convention. It's not a enforced by the Python interpreter. Now, so I just mentioned about the constants here. This is an example, and then let's actually take a look at the assignment statement. How do you create a variable? Now, this is different from many other languages where you have a declaration versus definition. In Python, you have an assignment. This assignment statement creates a variable. This is the first time it starts, and it will come into existence through this assignment statement. And now, assignment statement cannot be part of another expression. So this is a statement. On the left-hand side is a variable name. On the right-hand side is an expression. An expression is usually means it's a combination of an operator with its operands or multiple or composed together, but it's an expression that results into a value. And here's some examples. You have first name. It's assigned with this string. Now, keep in mind, the string object is immutable. The word immutable means it cannot be modified. This is an object in Python system. Now, this first name is a variable name that refers to this object. The object itself is not modifiable. All right. So, and then you have a second name. Here's just another example. You may use those variables in an expression like this here. These are associated, like first name now is associated with Ken, which is a string. So the type of this first name is a string object. And so it's a string object. When this plus here would be a concatenation. So we're concatenating with other strings, and this concatenation can be essentially chained. You have more because the rules of associativity, if you got multiple, this is just like how you use your math, right? So a plus b plus c, you can evaluate from left to right. So this will be evaluated from left to right because the plus is a binary operator. Okay. So variables serve two purposes. One is to help programmer keep track of data, and that data may change over time. And then also allows programmer to refer to complex piece of information with a simple name. Well, this is straightforward. Now, integers, in real life, the range of integers is infinite. However, in computer, we have a finite amount of a memory, or that we kind of always have a limit on that. So in Python, the integer limit is actually quite large, actually. And actually, I think this might be a typo here. It's just basically -2 to the power 31. Now, it says there's a typical range, although you can store actually larger numbers too. It's the Python will take care of the large numbers, in fact. And then the real numbers have infinite precision. The float, it's because the way we present real numbers in computer is through floating point numbers. Okay. Here it mentions about the typical range, and the typical precision about 16 digits. So a floating point number can be written using decimal notation or scientific notation, which you're familiar with in your math. Now, in the representation in this program, you have this character E that separates between the mantissa and the exponent, right? So the exponent is the number to the right-hand side of the letter E. And then the left-hand side is the significand. All right. Now, decimal notation like this, and this is the scientific notation. So the meaning, of course, this is how you apply to the, it's a base 10 to the power of, 10 to the power of whatever that number is. That's the exponent part, okay? And the character literals look just actually like the string literals. In Python, there's not a whole huge differentiation. You can use single quote or double quote. It can, contains just a single character. That's a single character. And you can use this ORD function that means the ordinal to convert a character into the code point in the ASCII character set. Okay, ASCII character set is a way to represent numbers and the other characters as an integer number. And then what are expressions? So a couple of different expressions. So first of all, the literal is simple. You value it to yourself. It is the value, basically is literal. And then a variable reference, if you just have a variable reference, that will evaluate to the current value. When you use a reference, variable reference, basically as part of the expression, that evaluates its value. That's straightforward. That's what a variable is for. And then the expressions are provide easy way to perform the operations on data values to produce other values. And typically, expression is the result of applying it's a result of some operator with on is operands, and then the result of that is the result of expression. All right. So a couple of different common expressions. So first of all, the simplest kind, well, the most common kind would be arithmetic expression. And the arithmetic expression is basically expression using the arithmetic operators. You got this negation operator, you have exponentiation operator, which this is a kind of unique in Python. Many languages don't have that exponentiation. And then you have multiplication. Now division, there's two kinds of division actually. And this double slash is called the floor division. And this slash, that's kind of the real division. This division will be what actually mean like in math. This double slash is where you actually evaluate the result with a normal division, but then you only obtain the floor of that value. Like if the result is 3.5, then it will just return you 3. And then you have the modulo operator that gives you the remainder. And then you have addition and subtraction. So the operators, when you have multiple operators in the expression, so there's this rule of precedence. This is just follows the natural, how you might use it in math, writing a mathematical formula. And this is a kind of a straightforward and really how you understand normally. So the operators that take the highest precedence, that will be evaluated first. And then you can modify the precedence level or the order of evaluation with parentheses, of course, okay? And so there's this concept of the operands of the expression, they need to be actually the same type. If they're not the same type, actually you do need to make a conversion. We're gonna look at the example in a bit. Now, some examples here. 3 divided by 4. Actually, let's take a look at that. I'm not sure if this is correct. Now, actually, this slide has a little issue here. I just kind of spotted this, all right? Let's go back. 3 divided by 4 is not 0. This is actually, this seems to be out of date. Now, this is going to give you the real result, which would be 0.75, in fact. And yeah, this is no longer correct. Now, for multi-line expressions, you may use this backslash to separate. Here's you have a long, let's say you have a long expression. You can break this down into multiple lines with a backslash. That's a continuation. Now, you can do that. However, there's another way to do this, which is, in my opinion, would be more preferable. You can use parentheses. So you can surround this whole expression with a parentheses, and then you can break down into to multiple lines. All right. So there's two ways to do it. Now, if you have a mixed mode arithmetic expression, the mixed mode means that you have different types in that expression. Then you actually typically should do a type conversion, because Python will not implicitly convert a value for you. And you want to actually make sure they're actually of the same type. All right. Now, however, if it's between the numerical values, you have, you have a float, and then you have an int, and the int will be converted to the float automatically. So this will be fine. You don't need to explicitly convert. But typically, you should convert. Okay. So you have a couple of conversion function. Yeah, so happens that the conversion function actually, the name of the conversion function is the same as the type name. So you want to convert something to a string, to an int. Then you use this int function to convert to float. Use the float. To convert to string, use str. Okay. So if you convert integer 99 to a string, it becomes a string 99. So when you convert, you have to be careful though. When you convert a float to an int, you are truncating that number. Okay, so the fractional part will simply be dropped. Now, here's another example here. You want to use this plus operator between a string and a number. That's not going to work. You have to convert either one to the other type. So maybe you want to convert that profit variable to a string. So by using the string conversion function, and then you will be able to concatenate. So the point here is Python is a strongly typed language, even though you don't really explicitly specify the types, but still strongly typed. And one of the strengths of Python is it's got a huge standard library with many modules. So the useful functions and classes, sort of units of code, they're organized in libraries. Those libraries are called modules. Now, what is a function? A function is a chunk of code that can be called by name to perform a task. A function typically will have arguments or parameters. In fact, Yeah, these two words are typically used interchangeable, but usually when you make a function call, you pass arguments to it. In the function definition, you have parameters. That's kind of the difference there. And the arguments may be optional or required. If they're optional, means that you have default values for them, okay? So the function completes a task and it may also return a value, or it may not return a value. So for example, this is the built-in round function, then you can actually look up using the help function to look up in this interactive session of Python. So what you do is in the terminal, you just type Python or Python 3 to get into that program in the interactive mode. Okay, this is actually called a REPL mode, or REPL. So an example module would be math. You have math-related functions and constants defined in this module. For example, the apps is for absolute value. Well, the apps actually around, those are actually in the built-in module. The built-in module is always imported. You don't need to explicitly import. So those functions are available to you directly. Now, for example, if you want to use the constant pi from the math module, so you may just refer to that pi variable or with this dot notation here. So it's like the module name dot and followed by the name of it. This is basically here would be the constant pi that we're trying to use. You may also use a function that's inside a math module, math.sqrt for square root. You call that function, give it an argument of 2, and then you get a result. And you may also import the names directly so that you don't have to use math dot. The way to do that is you use this from the module name, then you import the names you want to use without that qualifier of the module name. So here, then you can use it like this. I would not recommend doing that, actually. It's actually better if you just prefix it with the module name, makes it clear that function or constant is from the library and not something that you define locally. And so when you write a program, you can basically just write the statements directly, like that's called a scripting, or just writing a script. And in that file itself is a module. And you can import that file with the name of the file without the .py. And then you can import that if you have things that's inside, and then you can use it like that. And it's through this import statement, you can use the code you wrote in the file and then use it in a different file. The idea is it helps you break down a large program into multiple files. Then it's just a way to organize your code. Let's take a look at one simple example, actually, before we proceed further. Let's see, make this a little bigger. Okay, so this is a simple example. We're trying to compute some properties of a sphere. So basically, if we are given the radius, we want to compute the diameter, circumference, and the volume of sphere. And we're importing a math module because we're doing some mathematical operations. We're going to use some functions from that math module. And here we are actually getting the input. So first, how do we get the radius? So then we just ask the user input from the console. And so using this input built-in function, and then they will request input from the user before it proceeds. It will stop until you put in the number. and it will proceed. Now, usually when you type something on the screen, it is considered a string by default. And so you have to actually convert that to, let's say you want that to be a float, and then convert that to float, it becomes your radius. And then you can use this in your expressions and the variable statements, the assignment statements. So here, we're calculating diameter through this assignment statement. So we basically now made a new variable diameter with an expression 2 times radius. That's basically a arithmetic expression, multiplication here. The result of that is evaluated and it's basically assigned to this variable. So essentially, you can also, another way to say it is this name diameter is bound to the value of this, right? And the circumference here, we're actually using the diameter that we just defined, and then we're gonna multiply that with the pi constant from the math module, right? And similarly, you calculate other things, then you can print them out with a print function, okay? So I want to mention about print. There's also the print statement where you don't use the parentheses. This parentheses here is a function call. You don't use parentheses, then there's a print statement. The print statement is obsolete. So try to use the print function. And so in the print function, you can give as many arguments as you want, but they will be just printed out one after the other. So here, for example, we're printing out a string followed by a variable, and diameter, the value of that is going to get printed out, which is a float. It will be printed out. So let's run this and see what happens. Okay, let's give a radius. Let's just say our radius is 100. So you see the diameter is basically 2 times that radius 200, and then you have some circumference. And that is, see, is a kind of long long precision. Actually, it has a lot of digits after decimal point. This is the default behavior. We'll learn how to control this. This can be controlled to print out, let's say I only want 2 decimal places, then you can do that, right? So we're going to look into that in a moment. Okay, so it's a simple example right here. Let's go back to slides. So that's some basics about data types and some expressions and statements. Now there's a couple more statements that you obviously need to know so that you can have some logic in your code. So basically, we're gonna talk about selection statements and loops. There are 2 kinds of loops. Well, just different flavor. They are more suitable in different scenarios. So they have the for loop, and they also have the while loop. And here, this is the for loop. So the for loop allows you to repeat a set of statements. And each repetition can be called iteration. It's more commonly called iteration or pass. And you may repeat your loops certain number of times, or you may repeat until some condition is met, and then you exit. So here's an example here. You have a for loop with this keyword for, and then you give a, you say each underscore pass, which is a variable name. In is the operator, a range of 4. So the range function of 4, this produces actually a sequence of numbers. Essentially, this object will give you 0, 1, 2, 3. The 4 numbers start from 0. And basically, each time it gets a value from that sequentially, from that 0, 1, 2, 3, each pass will be assigned those value during each iteration. Although we're not really using the value here, you may use it, you can print this out if you want, but here we're not using it. We're just essentially using this, say, we're gonna repeat this statement, this print 4 times. Okay, so it's printed out 4 times. So this is a typical format. You have this four, this is lowercase f, by the way, four variable in a range with an integer expression. And there's, we're going to look at a couple more examples here what you can do over here for range function. And then the idea is you can execute multiple statements here as the body of that four statements. Okay. So the first line is sometimes called the loop header, and the rest is called loop body. And the loop to compute an exponentiation for a non-negative exponent. So this is, so you have this range here, they say you're trying to compute repeatedly for a product. Each time you want to compute this by, multiply with a number, and then you repeat that whole thing a certain number of times. This is just one simple example how you might compute the power function, right? You have, the product that, you say you have 2 to the power of 3. What is the result of that? So you may use a for loop to do that. Now, the exponent, if it were 0, the result would be 1. Okay, so you kind of initialize this, the initial value of a product is 1, so which is correct. If the exponent is 0, then this is not going to execute. There's no yeah, the range of a 0. Let's actually try to run this thing. Range of 0. From 0 to 0. If we're going to, let's say, for in range 0, print okay, so you see it doesn't execute. So if a range of 0, it will not execute. So that is correct. This is what it's trying to say here. You may control the count through a count. Now this count, so first of all, already look at the example. The count is going to be starting from 0, 1, 2, 3. So the number 4 here is essentially like the stop condition. This is where to stop, but it will not include a 4. Okay. And to specify an explicit lower bound, that basically means where you're going to start. Instead of this, you don't want to start from 0. You want to start from 1 instead. So you can do this like this way. So if it's range of 1, 5, you have 2 arguments here. This is the first number is the start. Second number is the stop. So the start number is 1, but it will stop at 5. It will not include 5. So it will be 1, 2, 3, 4. This is the end. It will be a sequence of those 4 numbers. So during each iteration, count is going to be assigned one of those numbers sequentially. Okay, this is kind of how this for loop works. And this is just similar ideas. They're going to move past that. Okay, so augmented assignment. So far we have seen just assignment with the equal symbol, right? And so you can combine the assignment with a arithmetic operator. And then if you have those things together, it's called augmented assignment. So if you have a plus equal 3, this is equivalent to a equal a plus 3. So we're assigning the result of a plus 3 into a. All right. So the format is a variable operator equal and the expression. And this is equivalent to this. So equivalent to you have this variable operator expression. Okay, so this is assuming your operator is a binary operator. So it takes 2 operands here. And now typical error with the loops is that off by 1 error. So this range of 1 and 4, 1 through 4, this is actually, it's going to give you the 1, 2, 3. Okay, it does not include 4. Now, a range actually returns, a list. And you can just use this list function here. You can turn that range that is a sequence, the result of a range, and turn that into a list. A list is a kind of a collection of values, and it's pretty versatile. You can put all kinds of data types in it. It can be mixed data type, usually, but although it's not a good idea, but you can, okay? So the strings also sequences the characters, and the values in the sequence can be visited with a for loop. So the for loop, because now remember the string, previously we'll look at a string is a sequence also. Like the range function, the result of that is a sequence. So you can use this in operator to test the existence. So for character in a string, so it is going to look through the characters 1 by 1, starts from H. So you see this prints out H, I, space T, like that. So here in this print function here, we'll specify another argument and equal to a single space here, so that we can print out as if, after each character, we'll print out each character and then followed by a space. That's what it means. Now, the usage of this range function takes a third argument as well. A third argument is the step value. So previously, we say, range from 1 to 4, that gives you sequence value 1, 2, 3, right? That's because the step value is by default 1. What if the step value is 2? So here, this example. So it will start from 1, and you're going to add 2 to get the next number. That would be 3. The next number will be another adding 2 to that number is 5, right? So 1, 3, 5. Each step is 2. So that's what this third argument allows you to do. Okay. You may also count backward in the sense that, okay, you have a range, you start with a high number, 10. You want to end with 0, not including 0. And then your step is a negative number, so you're going backwards. So essentially you start from 10, it goes to 9, 8, 7, all the way until 1, not including 0. Remember the stop number is that's not included, excluding that stop condition, okay? All right, so first I mentioned about formatting. When you print, you can do a precise control of printing your numbers or your variables and then have them formatted in a particular way. So here, first, I'm going to kind of just introduce some concepts and talk about how it used to be done, the old style, but then also I'm going to talk about the new style. Okay, you may want to pay more attention to the new style if you're not familiar with. So that's assuming we're printing out the text in the console, which we use a lot. Now, console type of application is not the only type of application, right? You can have a GUI type application, right? But even in the case of a GUI, you're going to print out your text in some kind of a label or some kind of a widget, right? Then just still same idea applies, how you want to control the output when it gets displayed. Doesn't matter if it goes to a GUI element or it goes to the terminal, okay? It's the same thing. So there's this concept of field width, and the field width essentially is the idea of formatting your data by controlling the number of spaces before or after the value you want to print. And so you have this concept that's the filled width. If we have width of 10, is the equivalent of 10 spaces. Within that 10 spaces, you may print some values in between, maybe in the middle, maybe to the left, maybe to the right. Okay, these are things you can control. Now, so here's an example. When you do a print, you're going to print out here, printing each time we're printing two numbers. And by the way, the print will automatically add a new line. And that adding new line automatically can be changed as well. Okay. So previously we saw that end argument, instead of a new line, what we say we just add a space, right? So you can control those things. This is just default behavior each time it prints out a new line. So you have the exponent, all right? And then you have another number that's printed out. And the way to format, so a very common, this is the old style. This is how it has been done for a long time. Starting 4 years ago, about 4 years ago, then there's this new feature that we're going to talk about next. So this is called using this percent operator. Now the percent, just recall in arithmetic operators, this is the modulo operator, right? So the modulo operator is the same operator, but just redefined to work on strings. And this, in the case of a string, the meaning of that operator is to format that string. So you got a format string, which may contain some, string with some format specifiers inside. And then on the right-hand side is the values you want to print that will get substituted into that format string. So here's this general format. You have the format string, and then you have datum, and the datum could be multiple values. And then in this parentheses format with a comma separating them, this is actually called a tuple. This is a literal tuple object, right? So here's an example here. We'll print. Now you see this format specified here. By the way, in this string, the format string may contain whatever characters you want to print out, just a message like hello world, that's fine as well. But then as soon as it sees this percent sign followed by this, a number, and then another type. Now the type D is used to print out integers. And then number 3 over here is saying the field width is 3. So you want to print this number within the space of 3 spaces. A negative sign here means we want to align this to the left in that space of 3 spaces, okay? And similarly, this is a sort of a span of 12 spaces. This is the width of 12. And then in there, I want to print out the exponent. Well, 10 to the power of exponents, right? This is the exponentiation operator, remember? And so this is the one way to format with the string format operator. Sometimes it's called a string format operator, or it would not be a modulo, right? This is not on numbers, and string is just redefined to become the string format operator. And so the specifier here that we saw start with a percentage. The reason is using the percent operator here is because these things start with a percent. And this is actually borrowed from C. This kind of format is familiar to the C programmers. You have a percent, you have a field width, and with a dot indicating this is used for floating point numbers. You want to control the precision, how many decimal points you want, decimal places you want after the decimal point. This is how you can control it. And so here's a simple example here. You have a salary equal to 100, and then you print out that salary, and now you want to control the format here with percent 0.2 F dot 2 means 2 decimal places, and then F actually stands for fixed format. And then you have 0. This is 0 is for I believe it's for padding, and it will be padding to if it needs padding, it will be using 0. Okay, so in the case if this were 100, right, and then you can pad this with a 0 after decimal point, right? It's typically what that means. Now, there's a new style of formatting in Python called F strings. F stands for formatted or formatted string literals, called F strings. I would say this would be the recommended way of doing string formatting. If you want to format your string, I would recommend you use F strings instead. Now, the F strings are more intuitive and just more readable, actually. So the general format of a placeholder with a format specifier. So you can, in your string, the way to make an F string is start with the letter F. It could be a lowercase or uppercase F. Doesn't make a difference. You typically just use a lowercase F. Followed by your typical string, right? Single quote, double quote, doesn't matter, or even triple quote. Now, inside there, you see this pair of curly braces. Inside braces, you have things you can put in there. That would be this typical format placeholder colon format specifier. The placeholder can be an expression like 10 plus 2. That's fine. This will evaluate that expression and then print out 12, right? Now here, we're going to say this expression is going to be essentially a variable reference. A variable reference is also an expression, remember? Okay. So here, of course, this will be evaluated into the value of salary, will be 100. And I want to format that floating point number. So that format specifier comes after the colon. All right. After the colon, we have this dot 2F. So this is still very much similar to what we saw with the format specifier for the percent operator, right? So again, this also means we want to have 2 decimal places and then sort of print out the same thing as before. This is equivalent to what you saw before right here. Okay, see this? And now we're going to use it this way. So we'll no longer use a second operator operand, and with the percent here, this will be essentially all part of that string. Inside it, we have this placeholder where it's going to evaluate expressions directly. So you can, then you can read like your salary is salary, and then we just format it this way. Okay. So this is very intuitive. By the way, this dollar is a literal dollar, is not part of the expression that is necessary for the placeholder. By the way, it will be printed out as is. So don't get confused, because some language will actually require you to use a dollar. That's because the part of the format, right? But this is not. It's just the only thing you need is the print curly braces. Actually, let's take a look at an example of F strings. It's best to look at the 3 example. Now, so of course, the simplest F string is just a regular string. If you prefix that with the letter F, that becomes F string. Well, although usually this doesn't mean you should use it this way, because now what's the point of using F string while you're not having any placeholders? So anyway, just showing you, you can still have an F string with a plain string without any placeholders inside. That's fine. But then typical usage, of course, you want to do some formatting with expressions inside. So here you have a placeholder. The placeholder has an expression name. So of course, this is going to print out the name, Johnny, substituted with that value here, and it prints out hello, Johnny. So that's actually just run this. So we're going to just follow along here, the result. So it prints out the hello world. and this prints out the hello Johnny. And then here's another, like what you kind of already saw this in the slide, 10 plus 2 will be evaluated into 12, okay? Now, suppose you have a variable amount due, which is a float. How do you know it's a float? Because you have this dot, okay, decimal point here. So that turns this number into a float. So you hover over this thing, it's going to tell you the type is float. Now, so then we can actually use this as a part of expression. And again, so just showing you you can have an expression here, amount due divided by 12.0. And then we're going to format that with a dot to F. It means we want to have two decimal places. The result of that, right, is 416.67. This would be the monthly payment. Okay. Now we have a number here, which is a long floating point number. And then we're going to print out this. This is another way to format. You may say, oh, I want to use a comma separating out those groups of numbers so it's easier to recognize. So when you use a comma, it's going to print out this number like this. 1, comma, 2, 3, 4, comma, and that group is a 3. This is locale specific. Okay, this is what you would expect in this US locale. Now, in different locale, different language, obviously, like you want to target different geographic location, your numbers may be formatted in a different way. And then you have to deal with, what's the default locale, right? There's going to be ways to deal with that. But just, as far as we're concerned here, we're talking about the default locale is how we would like to read the numbers in the US culture. So this comma separator can be also combined with the rest of the specifier. We want to control the precision, right? So here's the next thing that prints out, just dot 1, 2, okay? Now, we can also print out a percentage. So if your discount is 0.5, float, and then you can print this out, say discount one of this is a 50%, with a 1 decimal place, so 50.0%. It's like a conversion, okay? But it's convenient sometimes. Now, you can also do scientific notation. Scientific notation is the type letter is E. So you can still use the precision 0.2 with the E. So the precision, 2 decimal places, 1.23 in scientific notation here, right? E plus 04, that's the exponent. Now you have an integer 99, we want to specify the field width. By the way, the field width is only the minimum. If the number is actually bigger than 10 spaces, it will expand to allow you to print that out. But if it's less than 10, well, actually, yeah, if it's less than 10, you see how this is automatically aligned to the right. That's the default behavior, by the way. You can change that default behavior to align to the left or to the center. By default, numbers align to the right. The strings are aligned to the left. That's the default behavior. So in fact, I'm curious if we're going to say if our field width is just 1, see what happens. In this case, it just prints out the whole thing, right? See that? Okay. Now, the next thing is you can combine, of course, the field width with the rest of the stuff that we have seen so far. So here's a floating point number. We're using comma to separate the groups of digits to make it easy to read. And then we're going to have a precision of 2 decimal places. And then the field width is 12. So that's the result of this. See that? Right aligned with the default behavior in terms of alignment. You got the comma separation. You have 2 decimal places. Now, you can align the number to the center of the field by using this this character, this caret character, right? So you see it when you print it out. So we'll put some characters in both sides so we can see how it looks. So this is actually roughly in the middle. Maybe off by 1, depending on if it directly fits into the middle. But visually it will be in the middle. Now, the strings are by default aligned differently, in fact. And so we say, well, how do you write a line? You can write a line with this greater than symbol, which is like the arrow to the right, right? This is how you remember this is a right align. If it's arrow to the left, that's left align, right? So you see how it prints out. Now, if I ignore this, the left align, it's going to be still left align because that's the default behavior. You see this? That's the default behavior. So this is just showing you how to actually make it a left align if you need to force it. In the case of string, you don't need to. One last thing to show is the concatenation. It works similarly with just regular strings. If then with the F strings, you break that long F string into multiple parts and then write them into multiple lines, they will be automatically concatenated. Without new lines, by the way, they're concatenated back into one single line. All right, as if you wrote that long F string together into a single string. So, all right, this is the concatenation. All right, let's back to the slides. All right, how do you select different parts of the code to run depending on the condition? So that's the idea of using if and if else statements. And these are called selection statements. This allows you to make choices. And how do you express condition? So then means we got to introduce you to a Boolean data type. A Boolean data type has 2 values, true or false. And for example, you have this expression 4 not equal to 4. Well, this is obviously false, and we know 4 equal to 4, right? So you have this comparison operators. So equals, not equal, less than, greater than, less than equal to, or greater than equal to. These are typical comparison operators. The result of a comparison expression is a Boolean value, true or false. And that expression can be used as a condition for your if statement. So here's an example. We have, let's say we got a number from the input, which is the area. And then we have an if statement here. So if area greater than 0, we're going to do the computation. Radius equal to, looks like it is the area of a circle. Okay. So we're, trying to calculate radius from an area, which is this, well, this code is probably problematic in math, apostrophe S. It doesn't seem right. I think what is meant to be is the square root, right? So you know how the math works, okay? So this is a little typo here. So this is the case where area is positive, which is good. We can do the calculation. Otherwise, it's an error. We say, well, just print out an error. The error must be a positive number. Okay. So this is a typical if else. If condition is true, you execute that first block of sequence of statements under if, and then you have else part, which is executed if the condition is evaluated to false. Now, keep in mind though, in Python, the indentation is significant. In other languages, many languages, the spaces don't really mean much, but in Python, it's about formatting that has significance. You have to have one indentation through a tab typically, and the tab may be placed by the same number of spaces, and they need to be aligned. So that will be, these 2 parts need to be aligned. So anyway, just use, typically you hit a tab, your tab, it may be a single tab character, or maybe it's replace it with the spaces, then that both will be fine. So just keep in mind that indentation is significant. So here's a simple logic in a graphical format. You ask a condition. If the condition is true, it's going to execute a sequence of statements 1. If it's false, the sequence of statements 2, which is the else part. Okay. And then you may also omit the else part. Is just say, I want to say if something is true and we execute something. Otherwise, this is skipped. And what if you have more cases to test? Yeah, you can do that. So how do you do that? So here's an example. Let's say you have the letter grade A, B, C, F, and then you have a range of numeric grades. So how do you do that? So you use if, elif, else. Basically, if, else, if, new the condition. So if the grade is greater than 89, say, well, you have an A. Otherwise, so it means you're less than or equal to 89, but your grade is greater than 79, then the grade is B. Otherwise, that means your number is less than or equal to 79, but also it's greater than 69. So this is how it works. And in the end, else is everything else. Otherwise, no more condition to test. It's all the rest. It falls into this category as a fail. So that's how that works. And then here, it will be a graphical representation how this evaluation logic works. You test the first condition here in the if part. Is it true? And then otherwise you execute some statements. If it's false, then you evaluate the next condition. Is it true? You can execute the statement followed by that elif clause, right? And then so on. Now, the course of action must be taken if either the condition is true, and then there are basically different ways to do that if you have multiple conditions. So let's say you have two conditions, number greater than 100, you say, well, that's an error. If it's less than 0, it's also an error, right? You can test them separately. Each one of them is a simple comparison expression here, but you can combine them with an or logic operator. Is logical operator or, then there's also logical operator and. So you can have two comparison expressions using this logical operator or, so either one is true, and then you're going to do this, okay? So the result is true if either one of these two parts are true. So that's the or logical operator. So what does the or logical operator means? If basically if either one of them is true, so you have true is true, true or false is true, false or true is true. If both are false, then it's false. So this is the or operator. And if you have and operator, logical and basically means it's only true if both are true. Otherwise, it's false. See, the only case where it's true is because then both are true. Then you also have a logical negation, not. So of course, that's the opposite of it, right? You have a true, then the result of the not A is false. And likewise for the false case. And so this is very typical. You're going to use your logical operators to make compound expressions. So far you have been introduced to all these operators, and then this is the symbols that you've seen. Now, in the case of evaluating a logical expression, the condition you may use in the selection statement, it has a property of a short circuit. Short circuit evaluation, what does that mean? It means if it's A and B, we know the only case to make this true is if both are true. And now, if A is false, there's no need to evaluate B. That's what the short circuit means. So if A is false, it will just end right there because it doesn't really matter what B is. The end result of this is going to be false, right? It saves time, and so that has the implication. So you have to keep that in mind, that B will not be evaluated if A is false. Now, similarly, for this OR logical operator, then you have, if A is true, we know the end result of that OR expression will be true, regardless of B is false or true. So that's another short circuit, right? Now, the other form of the loop is called a while loop. In the while loop, you use a condition. And that condition, if the condition is true, it continue to loop. If it only X out of that loop when that false, the condition becomes false. But there's other ways to get out of a loop. So typical format of this is, if the condition is evaluated to true, and then you're going to execute this sequence of statements in a loop, and it keeps looping many times. Now, this is sort of the representation of this behavior. You testing this condition. If it's true, it will execute the statements, and then it will continue the loop, going back and check the condition again. At the end of each loop, it go back to check the condition. If the condition becomes false at some point, it will exit out of the loop and it continue within the statement after that. Okay, so here's an example. You let's say you take a input from command line from the terminal, and then you get a data, and if the data is not equal to empty string, then you basically looping through. So you keep getting something from the end user. Right, this is where this, another input function call here does. You wait for your input. So if you don't input anything, then this is how you get out of it. Otherwise, it will keep adding that number up to the sum, and then the sum will be added, it will be printed out in the end. Now, because a while loop is also a loop, you can implement a for loop with a while loop if you want. So you always have a way to transform one to the other in an equivalent manner, okay? Maybe in one form, you have to write more lines of code, but they can be equivalent. So that's that. Let's actually see if we can take a look at a simple example. So let's say we have a simple game of lucky sevens, not really the same lucky sevens in the casinos, but just say this is, we have some simple rules here. Say we have two dices we're going to roll. If the sum equals to 7, and then you win $4. If it's not 7, you lose $1. And then you give an input of amount of whatever money you say you're going to put into the pot. That's essentially, the money you put into the pot that you may be prepared to lose. And the computation it's going to do is that it uses a random number generator to simulate the rolling of the dice. Okay. And it's going to loop through the computation of rolling the dice and then playing the game by modifying the sum of the money that you still have remaining until the funds are depleted. Okay. And then we also want to keep track how many rolls we have done and what's the maximum amount of money we have had at one point. And we'll print out those values. So there's a simple program about this little Lucky 7 game. So we import this random module. This allows us to generate some random numbers. And so first we're going to get some amount of money you're going to put down into the pot. That's the dollars variable. And then the dollars variable is, we're going to also make a new variable called the max dollars. because we're going to modify these dollars, and then the max dollar will not modify. Will not modify actually. And then we're going to maintain the count. The count at a max when we had a max amount of dollars, and this is something we're going to just keep track of the max amount of dollars. Also, we're going to keep track of the count at the maximum number of dollars while we're rolling dice, playing the game, right? So we're going to have also maintain the count. This is going to be increasing every iteration. So the looping condition is dollars greater than zero, so it's a positive. And if it becomes zero, it means your funds are depleted, and then we can stop. And then so each time we're going to increment the count by 1. This is using this, remember this, the augmented assignment. Now, in other languages, this may be called the compound assignment. Compound assignment or augmented assignment means the same thing. In Python, we call it augmented assignment. Now we're going to use this random module, this random int function of the random module to generate a random number between 1 and 6 inclusive. So just simulating rolling a dice, right? Have 6 numbers. And then you have, 2 dice. 2 dice we're going to roll. And if the end result of that 2 dice, we'll add them together. If it's a 7, we're going to win $4. If it's not 7, we're going to lose $1, right? So this is a use case of if else right here. Now, we're also going to check, because we're trying to figure out what's the maximum dollar during this whole play. So if the current dollar amount after this one play is greater than the current value of max dollars, that means that we need to change the max dollar to this current dollars, right? This is bigger. So we're going to change that, and also remember the count at the max. So this just loops over until the dollar becomes 0. Okay. And then we'll display the result. All right. So if we run this thing, let's say we start with $100. Okay, now you see you're broke after 285 rolls. You should have quit after 5 rolls when you had 105. So the best we did during this run, we actually just earned $5, and then, well, we didn't know to quit. We'll end up losing everything. Okay, eventually you can always lose. But if we run it another time, remember this is random roll of dice, so you're not going to get the same situation each time. So here, well, actually this time it took 880 rolls to lose all $100. So after we roll 71 times, we had $114 at that time. Okay, well, the odds of winning is not that great, so it's not a good game. So that's kind of just a simple illustration of some of the basics that I've covered so far. Yeah, hope that's a good review for you. Thank you.